Good morning, class. We are looking at section 5.2, the definite integral. All right. Again, we need to be comfortable with basic integration formulas. Here's the synopsis of the previous section, and what I'd like you to remember is that when you want to calculate the Riemann sum for the left or right or midpoints, just go with draw a line segment, okay? Calculate your delta x, which is b minus a over a, and use the line segment to your advantage. You need all the points on the left except the last one for the left endpoints. Every point except the first one would be for the right endpoints, and then the midpoints. They all give you an approximation. It becomes an exact answer when you take the limit and you let n go to infinity. That becomes an approximation class, okay? So that's the idea behind this. And so the Riemann sum gives us the following definition. I want everybody to pay attention to the definition of the definite integral. This is a definite integral class because it's a number. It is read, and we'll discuss that further in a moment. The integral of a to b f of x dx is this limit, the limit that was discussed in the previous page. So this is called the definite integral because it's a number. And it is calculated by this methodology, which is known as a Riemann sum. They are the same thing. Now, it represents the area under the curve if the function is a positive function. By the way, we are assuming a continuous function, of course. So let y equals f of x be continuous and non-negative over an interval of a to b. A definite integral is the limit as n goes to infinity. I hope you realize when n goes to infinity, delta x goes to 0. Why? Because class, what is delta x? B minus a over n. If n goes to infinity, delta x, the numerator is a number, remember that. But the bottom goes to infinity, this goes to 0. And by the way, delta x is, the numerator is not 0. And so having said that, the Riemann sum of the area of rectangles under the graph of the function y equals f of x over the interval of a to b. So this is the definition of this guy. Okay, the definite integral is defined as such. I have some explanation here, and I think the next page, you can read this on your own. I think the next page explains it better. So I want to go over the next page. All right, we want to discuss every part of this in case we haven't. Integration symbol, lower limit, upper limit, the integrand. Dx is called a dummy variable because in essence, it gives us what is the independent variable. If I change that to any other variable, it gives me the same answer. Just as an example class, if I wrote, this is the same as the integral of a to b f of m dm, it makes no difference, okay? It gives us the same answer, everybody gives us the same answer. So having said that, let's quickly go over this. The integral of a to b f of x dx is a number. It doesn't depend on x. We could use any letter in place of x without changing the value of this integral, okay? The integral of a to b f of t dt. The approximation is what is called the Riemann sum. It is called a Riemann sum after the German mathematician Bernhard Riemann, okay, after it's in, the one who developed it in essence. This is an approximation class. I can't emphasize this enough. This is an approximation, and it becomes precise when we take a limit. So this Class is an approximation. What is an approximation? Using the left endpoints, using the right endpoints, using the midpoints. And by the way, this is using the right endpoints. Normally we use R. So again, let me just write that for you. This is Rn, okay, class. All right, and when we use A plus I delta X. So it becomes exact when you take a limit and you let n go to infinity. All right, let's look at a couple of examples. We want to express this as an integral on the interval of 0 to pi. In other words, what is it that we want to do, class? We want to get here. Take a look. We want to write this one, the integral of f of x dx. We need to know a, we need to know b. A is 0, b is pi. Are you with me? Delta x basically changes to dx. We need to know what's f of x. So in a matter of comparison, okay, so we are comparing these two, okay, and delta x is dx. And so f of x sub I, this is f of x sub I, everybody, this is f of x sub I. So what is f of x? The same thing without an I. And so the integral of 0 to pi x cubed plus x sine x dx. Normally, going from here to here shouldn't really take that long. It should be fairly easy. Okay, class? Normally, it's easy. All right? Normally, it's easy. So compare and inspect and come up with the answer. Again, area under the curve is explained here, and this relationship is explained here. Delta x is b minus a over n. X sub I is a plus I delta x using the Rn, the right endpoints. Here's another example. Again, information at the bottom, at the top right. Those are for us to know. And so what happens next? That's what we are going to look at, everybody. So all right, the very first thing I want you to notice, 0 to pi, 2 pi. I'm interested in a and b, so I got my a is 0, my b is 2 pi. Now I need my f of x. So we have f of x dx is the same as f of x sub I delta x. So let's write that. We are comparing, everybody, okay? So when I compare that, I notice 2 pi, okay, over n, and that's dx or delta x, if you will, okay. And this is my function, sine. If you drop the I, in essence, it becomes sine x. Let's just make sure this is the case. Let's make sure this is the case. So we have a, we have b, delta x is b minus a over n. So let's write it down. So delta x is b minus a, that means 2 pi minus 0 over n. And x sub I, let's write it, x sub I is a plus I delta x. A plus I delta x is this piece, 2 pi I over n. Okay, and we know a is 0. We know a is 0. Okay. And we know delta x is 2 pi over n. So a is 0, b is 2 pi. We already know that. Okay. And so f of x is a function sine between 0 and 2 pi. And you can work it out and bring this one back, resulting in the integral of sine x dx from 0 to 2 pi. So again, sine of x from 0 to 2 pi, 0 to 2 pi. Okay. All right. If we want to evaluate this limit, we need to know some information. Some of them come from before, and some of them you have the proof in the appendix. You can look at it. The summation of 1 is n. I hope you remember that from algebra. The summation of c, if you have a constant, for example, 5, then it becomes n times 5, okay? C A sub I, the C can come out. If you have different terms, you do them term by term, just the way we do with integration and differentiation, term by term. That's really the idea. You can separate. A summation of I is n times n plus 1 over 2, and this was basically the sum of arithmetic sequence. Since that's the formula. Summation of I squared has this formula, I cubed has this formula, okay. N times n plus 1 times 2n plus 1 over 6, and n squared times n plus 1 quantity squared over 4. So you can use those formulas to evaluate the definite integral. And that's what we are going to do in this section. However, as of next section, we are using the limit, just as we did with the definition of a differentiation, we used limit. Everybody remembers that. So we are going to do the same thing here. With definition of definite integral is defined as such, we will use the limits. And ultimately, we go with the easy way out as of next section, and you'll see how it's done. But there is a question on the exam also, you have to use the limits. So with that being the case, we need to know what's delta x. Well, I hope you realize we are going to go from A to B. A is 0 and B is 1. So your function is x squared. F of x is x squared. A is 0, B is 1. So that's the first one. So let's calculate delta x, b minus a over n, 1 minus 0 over n, or simply 1 over n. And x sub I is a, which is 0, excuse me, plus I times delta x. So delta x, b minus a over n, x sub I, a, which is 0, plus I times delta x, which is 1 over n, we get I over n. And so let's stick with the formula. This is the same as this one, f of x sub I. So what is x sub I, everybody? I over n. So replace this with I over n, and it becomes the summation. So take a look. Here's the formula. We need f of x sub I. So f of x is x squared. So this is equal to the limit as n goes to infinity of I equals 1 to n. F of x sub I, replace the x with I over n, so I over n squared, times delta x, replace it with 1 over n. Okay, now, remember that what's going on here? The limit pertains to n, so everything involving n remains. And the summation pertains to I. So anything involving I remains. So this is I squared over n squared. So I hope you see that n squared and n becomes n cubed. So you can take the 1 over n cubed out of the summation sign. I going from 1 to n, I squared. So take a look at this because I want to show you how to calculate this fairly easy. So first, simplification in this format. What is remaining in the summation? Only anything involving I. So the limit of 1 over n cubed, summation of I squared, everybody. What is summation of I squared? Replace it. Replace it. Now, what happens next? First, again, I want to make sure we understand what happens here. Right here, this summation is replaced by n times n plus 1 times 2n plus 1 over 6. Now, I'm going to show you how fast you can get to the answer. You don't even have to multiply the top. First of all, the bottom is 6n cubed. What about the top? I want you to notice the first term, n times 2n, the first term, everybody. The leading term, everybody. N and 2n. That's 2n cubed. I hope you see that. What about the rest? Do we need them? It has no effect. Why not? The leading term is 2n cubed. What is the limit when the numerator and denominator have the same degree? 2/6 or 1/3. So maybe I write 2/6. 2/6, which is 1/3. So I hope everybody is comfortable with that. Okay, everyone. 2/6. We're going to do one more as an example. This thing is tedious, class, but it is illustrating the fact that differentiation deals with limit when it comes to its definition. So does integration. All right. We want to do this one. Again, let's find out what is our f of x. X squared minus 4x plus 2. The limits a is 1, b is 4. So f of x is x squared minus 4x plus 2, and a is 1, b is 4. Okay. Delta x, everybody, b minus a over n, 4 minus 1 over n, or 3 over n. X sub I, a plus I delta x. A is 1 I times delta x. So let's see what happens quickly. Delta x, b minus a over n, 4 minus 1 over n. X sub I is a plus I delta x. A is 1, I is I, and delta x is 3 over n, 3I over n. So what does it mean now? Let's go with f of x sub I delta x, which means this class. So I'm looking at f of x sub I. F of x sub I, that means f of this, 1 plus 3I over n times 3 over n. And this is what I mean is tedious. It does take a little bit of a time to calculate this. So what is f of 1 plus 3I over n? Replace each x with that. Let's do that. So the limit as n goes to infinity of the summation I going from 1 to n, parentheses 1 plus 3I over n squared minus 4 times the parentheses plus 2, and the whole thing times 3 over n. Okay, everybody? So you are replacing x in x squared, x in minus 4x. Now this expression needs to be simplified. And I'm going to assume everybody can do that. So I'm going to quickly show you the next step and maybe intermediate step in a moment. That 3 over n remains. The bracket simplified to this. Let me just write a couple of things in between for you. Okay. So 1 plus 3i over n squared, this part, class, is what? 1 plus 2 times the 6i over n plus 9i squared over n squared. So that would be the first one. Okay. The second one, minus 4 times 1 minus 4 times 3, 12i over n. And finally, we have the number 2. Okay, so you are going to put all of this together in descending order. And so Let's quickly do that. So 9i squared over n squared, and then 6i over n minus 12i over n. Let me use a different color for that. So this two, what color can I use? Let's use this one. This two add up to negative 6i over n, okay, class? Okay. And 9i squared over n squared sits in front. Then we have two numbers, 1 minus 4 plus 2, they add up to negative 1. So I hope you see that. 1 minus 4 plus 2. So 1 minus 4 plus 2. Okay. So having said that, this is what we get. And now let's separate them in the following manner. Take a look at what happens. Everything involving I remains. Therefore, we can write it as follows. This piece, I can take the 9 over n squared out, and I have I squared. Minus 6 over n out, and it's I, and it's minus summation of 1. Now, one by one, let's see what happens. So we have the limit, okay? And we can apply the 3 over n by this one, and by this one, and by this one. So we can distribute the 3 over n. So this becomes 27n cubed. This becomes minus 18 over n squared, and this one minus 3 over n times summation of 1. Now let's do one by one. So we are going to replace this one as we did in the previous example with this. And as you recall, okay, so I want to give you the synopsis of that. As you can see, this numerator becomes what? 2n cubed plus who cares what, okay? That's for I squared. For I, and the denominator is 6, okay? For I becomes n squared. And again, of course, this is easy. You can write actually both of them. This is n squared plus n divided by 2. And the top one, summation of 1 is n. So take a look. I want to make sure everybody understands what happens here. So 27 over n cubed, summation of I squared is this guy, right? Minus 18 over n squared, summation of n is n squared plus n over 2. And this one is minus 3 over n, summation of 1 is replaced with n. I hope everybody can see that. Now let's do it one by one. What happens here? The degree of the numerator is 3, the bottom is 3, 2. So this becomes 27 times 2 divided by 6. All right, we lost the connection, so let me quickly recap a couple of things. I don't know how far we went, so let me just go back to this step. I think everybody was with us when we went over this part, okay, and we used squaring 1 plus 3i over n and squared that. Then we distributed the negative 4 plus 2, and we ended up here. I hope we didn't miss that. It simplifies to this. And then we take 9 over n squared out. We put summation of I squared minus 6 over n out. We put summation of I, so on and so forth. I hope the recording have that. And then you can multiply 3 over n, distribute, and this is what you get. Finally, I squared, we already know it's 2n cubed, the numerator over 6. We are going to replace that. Summation of I is n squared plus n over 2. We're going to replace that, and summation of 1 is n. When we do that, what happens? This one becomes 27 times 2 over 6 because we're taking the limit and we let n go to infinity. The degree of the top and the bottom are both 3. The second case, degree is 2, so minus 18 over 2, and the last one minus simply 3 because n and n cancel each other. So 27 times 2 over 6 minus 18 halves minus 3, and the answer is negative 3. Okay. So I hope everybody is comfortable with that. All right, class. Okay. The next thing is just understanding the definite integral as the difference of areas. Okay, if the function is positive, it represents the area under the curve. Okay, if it's not, is the difference of areas. The area above is considered positive and below is considered negative. Okay, if you want the area, you have to go with an absolute value. I want you to know that. Okay. So the Riemann sum is the net area. That means a difference of areas. Okay. So just for the sake of argument, if you look at this function, some of you already know this is an odd function and it looks something like this. So with the concept of a Riemann sum, this ends up being 0 because the area under and the area over are the same. They undo each other. Okay. So because of the odd symmetry, if you will, let me just write that. It's called odd symmetry, okay, class? Okay, so let's look at this concept. Let's look at this concept. Starting with this simple example, the integral of a to b 1 times dx. First of all, the reason I put 1 class, because if I don't, it may be, you know, some students cannot see it's 1 times dx, so y or f of x equals 1, which is a horizontal line. I wanted to make sure you see that. And so you draw a horizontal line and you want to cover it from a to b. Now, a to b are just any numbers on the x-axis. We don't know, but b is larger than a. A can even be negative. It doesn't matter. What matters is this. This is a rectangular shape. Why? Because the width is clearly b minus a, and the height is fixed at 1. Okay? Therefore, it's the width b minus a times the height 1, and you have the answer. Now, since the next section is coming up, I'm going to explain this to you. In the next section, we will look at this idea that the integral of a to b f of x dx is f of b minus f of a. That means find the antiderivative here. For 1 is x, and I don't need to write the constant because it makes no difference from a to b. And if I plug in b minus plug in a, I get to the same answer. The idea is the area works because we have a geometric formula for it. This is called FTC, Fundamental Theorem of Calculus works, and that's really representing that it works. I wanted you to see that. We are jumping ahead, but it's worth looking at it. In this case, y equals x, or f of x equals x, the line that goes through the origin. And we want it from -1 to 2, okay? This portion is from 0 to 2, and this one is from -1 to 0. So what I want you to notice this, okay, let me use it. Okay, let me use the proper coloring here. So this one, since I've got this one has coordinates -1, -1, and this one has coordinates two. Okay, so for a right triangle, the base and the height are the legs. So half of base times the height gives you half of 2 times 2, which is 2 for the green area, and the other one is half of 1 times 1. Please understand the legs are positive, okay? The dimensions are positive. 1 half 2 times 2, 1 half 1 times 1. So the difference is 3 halves. This is using geometry, it can work. I want to show you that the fundamental theorem of calculus says the answer is 1/2 x squared, because that's the antiderivative from -1 to 2. So you plug in 2, and then you plug in -1, and I hope you see it gives you the same answer. We'll discuss this further in the next section, but I'm showing you the definite integral using FTC, and the area, they give us the same answer. Of course, it is important to see that is the difference of areas. So having said that, what I'd like you to do is to do this graph at home from -4 to 1 integral of 6x dx and show it's -45 class. Now, definite integral has a lot of properties. I want to go over them quickly. The integral of f of x dx as we go from a to a is 0, because it doesn't cover any area, because delta x is 0. I hope it's clear to everybody. Okay. Sum and differences, just the same, just cut them into pieces. As you can see, this is f of x, this is g of x. Add them up, you get f of x plus g of x. The area under the curve for f of x, assuming those are both positive, and the area under the curve for g of x, add them up, and that becomes the area for f of x plus g of x. A picture is worth 1,000 words. Scalar, if you have a number and you multiply, see what happens. For example, you have y equals f of x versus y equals 2 times that. If a function is larger, okay, so it's the definite integral in, of course, a specific interval. If it's true from a to b, if f is larger, f is above the g, it covers the larger area. Again, we are looking at only positive function to make some sense out of this. It's easier to follow that. All right, bounding, okay. If we have the minimum value and the maximum value for the function, we can see that this is what's going to happen. I hope it's clear to everybody. The area under the curve, okay, for the minimum, it becomes a rectangular shape with the, and in all cases, the width is b minus a, in all 3 cases. But the height, f of minimum, f of maximum, or f varies. That's why it's between the two, m times b minus a. In all cases, class, this is the width. Okay, b minus a. So lowercase m, uppercase m times b minus a, and f of x dx. Now this is extremely important. This comes really handy, splitting or additivity. They say if we go from a to c, what you really need to notice, these two are the same. Okay, class. A to b and b to c, they add up to a to c. That's the idea. Also the opposite. So for example, we go from a to b and then b to c, this is what we get. And the opposite rule says the integral of a to b is the same as minus the integral of b to a, and simply because delta x, which is b minus a over n, becomes a minus b over n. If you have a constant, just the same as the mean and max times b minus a. If f is a positive function, its integral is positive. I think it's self-explanatory. I highly recommend you guys go over that and get comfortable with that. I want to quickly finish a couple of things. So let's go with this example. We are given the integral of 4 to 9, negative 3 to 9, and we want negative 3 to 4. Okay, class? So I hope you see that what number is in between. Negative 3 is the smallest one, 9 is the largest one, and it's 4 in between. So I'm looking at this splitting idea. So from negative 3 to 4 plus 4 to 9 is the same as negative 3 to 9. So pay attention to smallest one, class, is negative 3, largest one is 9. So negative 3 to 4, 4 to 9 is negative 3 to 9. Plug in and find the missing one. It's really simple. Again, they don't even have to go in that order, but that is the best methodology. Okay, minus 3 and 9, minus 3 and 9, 4 in between. And when I say not in that order, even if 4 is not in between, let's say it's 15, that still works. I want you to know that. So just plug in what you have and what you don't have. The first one is missing, and it becomes 25. In other words, you are really looking at a simple case of an algebraic equation. A simple case of an algebraic equation, everybody. Let's look at one more concept as far as the area is concerned, class. We want to use the geometry to evaluate this. By the way, later on when we learn more formulas for integration, this can be done in calculus too. Okay, it uses trigonometric integration, but for now we can't do that. So let's go with the graph. I hope you recognize that if you call this f of x and you calculate it, what it gives you is really a semicircle. So first, we are covering this from negative 3 to 3. That's the function. So if we call this y, okay, and we square it, okay, if you call this, okay, this is the graph. If you call this and you square, so right here, class, right here, if you square this, you get y squared equals 9 minus x squared. And that is what? X squared plus y squared equals 9 is a circle centered at 0, 0 with the radius 3. This one. This, okay, is a circle centered at 0, 0 with the radius 3. However, so in other words, here's what we have, okay. However, because it's the square root, we just have the top half. If it was minus, we would have the bottom half. It doesn't matter. So the area would be what? The area would be half of the area of a circle. So area of a circle is pi r squared. We need half of it. Pi r squared, everybody. And we know the radius is 3. So pi times 3 squared is 9 pi. Half of it gives us 9 pi over 2. So what did we do? We used a geometric shape. We happen to have a geometric formula for the area. We find the answer. Let's look at the last question, class. Same situation. We have a bunch of definite integrals. Okay, we have a bunch of definite integrals, and we want to answer some questions. So we have 1 to 3, 3 to 7, okay, for f of x and f of x, and then from 1 to 3 for g of x. So the question is, what is this one? 3 times f of x dx. So basically take the 3 out, everybody. Take the 3 out. So 3 times 6 is 18. I hope you see that. Very simple. So number 3 comes out. You already have this. 3 times 6 is 8. So we are using various properties of definite integral. All right. We use f of x. We take the 2 out. We use g of x. We take the negative 4 out. So let's rewrite this as follows. So we have f of x dx from 1 to 3, which is 6. So 2 times that. Okay. And then minus 4, we have g of x. So minus 4 times minus 4. So we have 12 and 16. They add up to 28. What are we using? We are using the properties to do this. We are using the properties to do this. We want 1 to 7 for f of x. We have 1 to 3 plus 3 to 7. So you just add up 6 and 9. Okay. We are using the properties. In this case, this is the splitting property, the additive, if you will. Finally, the integral of 3 to 1 f of x dx. So let's go back up here. We have 1 to 3. What is 3 to 1? The same thing, negate that. Minus 6. So this is also one of the properties that we discussed. Minus 6.